don't want to pollute your idea. I said, don't turn around! Let me turn this car around. You're just so good, you're not peeking. Don't peek! I'm checking you should peeking! Okay, turn around and see if mine looks like yours.
Not exactly.
Is it really close?
No.
What does a grade of 1 mean? 45 degrees. It's 100% grade.
Oh, the tangent table.
Yes, it's the tangent table. Oh, the connections. Yes, the connections. It's a tangent table. If the grade is equal to 1, that means the tangent equals 1. 100%. It's got a 100% grade. The only way to have that is if the rise and the run are the same. Now, I try to put 1.05 in parentheses. It's almost equal to 1. It's 1.05. But that means the triangle should look like that. It should have the same rise as run, which means this guy essentially should be 45 degrees. So why doesn't that look like 45 degrees? Please tell me your name again.
Jesse.
Jesse, go.
This is how the graph is set to
Yes, sir.
the screen, so
It's the Zoom Stat Fit. That's the kicker. So when you look at that graph, Jesse, perfectly said. So Jessica, the answer to your question, which is an awesome question, is Jesse's awesome answer. This is 2 units on the x-axis. This is 2 units on the y-axis. It's not a square axis. It's a rectangular axis. That's the problem when you use, good, you see? That's the problem with when you use technology to fit things to a rectangle or a given shape.
Okay.
It's not square. One of my biggest gripes about the TI-84 is that they give you a rectangular window and not a square one. They give you a rectangular window, yeah? Now I have a theory as to why. You actually have a quiz on it in a couple weeks. It's called the golden ratio. It has to do with that and the appeal of what's called the golden ratio. When you type Zoom standard in your TI, when you use the Zoom standard, it goes -1010, -1010. That sounds like a square, doesn't it? 20 wide, 20 tall, but yet this is not a square, is it? You notice there's also a setting on here called z-square?
No.
There's a setting on here called z-square. I'm not lying to you. I think it's actually Zoom 5, I believe. And what that does is it scales the windows into a look as though it were square. Which begs the question, why don't you make the window square in the first place?
Yeah.
Again, Cesar has not emailed. Cesar is the tech guy at TI who despises getting emails from me, I'm sure. I'm like, hey, I found a bug, Cesar. It's like, yeah, we know. I'm like, yeah, you didn't fix it yet. Yes, I know. So whenever I ask him, he doesn't have a good answer for me. I have a theory. We'll get back to my theory eventually. But. So anyway, Jessica, excellent question. Really, really excellent question.
Okay.
Because it's the way it's scaled. You can make it look square by simply realizing, now here's a really quick, long answer. The width of the window is 1.5 times the height of the window. It's 1.5 times as wide as it is high. So all you've got to do is make this guy match this proportion by making this guy 2/3 of this, or this guy 1.5 of this, and then it'll be square. But rather than deal with that, just make sure you're looking at the numbers properly.
Okay.
Right? Assume it's not drawn to scale, because you know what the news doesn't do anyway? They don't draw to scale. And sometimes they actually, I just saw this, I made a 243 quiz out of it. Measure 92 on the ballot right now, labeling GMO foods. Yes, yes, yes?
Yeah.
A graph came out,
Yeah.
and it said here are all the campaign donations that have gone towards Measure 92 and the zip codes they came from. And purple was listed in purple circle. Let me show it to you. Let me show it to you real quick. I could probably get the image up. It's your question answered, but in a different context, Jessica. And it's such a good one. Measure 92 GMO. Let's see if we can go with an image search for this one. Look for the map of the United States with purple and green circles on it.
There it is.
Did you see it?
Nope, just kidding.
Oh, I did see it though.
I think so.
That?
Oh, there it is. Yep. So the idea of this image is the purple circles. This is where Monsanto is headquartered. No great surprise there.
Yeah.
Are donations to the No campaign. No, we don't want food labeled a GMO. No. Green. Notice there's a large circle around Portland. Actually, there's many circles around Portland overlapping each other. They're kind of hard to see, really. They're the ones that say yes. Big one around LA, big one around Portland, one up here in like whatever town that is. I mean, that's Minnesota somewhere. St. Paul's got one, looks like, or Iowa, somewhere around Illinois. So if you look, there's more purple than green, yeah?
Yeah.
How much more purple than green? Ish. If you had to say there's this many times more purple area than green, what would you say?
Hard to say.
40, 35?
So do it this way. Realize too that there's green in here. There's three circles on top of each other here, and there's a bunch of purples in here. It's very tricky. And what I did was I blew the graph apart. I pulled all the circles apart from my 243s. It ends up there's about 4 times as much purple as green, which would make you think that there are, for every $1 in the yes campaign, there are $4 in a no campaign. That's logic, right? 4 times as much, 4 times as much.
Not even
That's
double.
not, no.
It's just barely under double. That's actually been updated since I took the screenshot last week when I did the quiz. Why would the number be roughly twice, but the image is quadruple? Good, I love this look. This look is saying, I don't understand. Good, love this, love this. What mathematical, I think they did it intentionally. I can't prove it. Michael?
Like the number of people in the green areas is larger.
Oh, what you're proving to me, thank you, you're proving me a parallel comment, which is where do the yes versus no votes come from? And generally they're going to be more liberal towns, right? That's why Illinois kind of surprised me. That kind of blew me for a loop. But then Monsanto's right there too. Oh, they're in Missouri actually. But yeah, so it makes sense the size of the circle is proportional to the population of the town. Love that. I want Illinois to be bigger in that respect too, right? Please, tell me your name again.
Anya.
Anya, please go.
I have no idea, but it doesn't have something to do with the residual data.
It's a purely mathematical reason, believe it or not. The data, I trust their data because I can't disprove it because I don't know how they're collecting it. But it's how they're presenting it. There's a definitely statistical error that is often made in the news. Brittany?
Well, I have a question.
Oh, go ahead.
Sorry, does that say negative?
Where?
Underneath
Janelle,
no, where it says
cash
cash
on
on hand, does it say negative 74?
Yes.
Oh my God, it does. I didn't even notice that. That wasn't negative last week. They're updating this data. That must have been they overspent.
Yeah.
I guess.
The corporate contributions are such a huge difference.
Yeah.
Cool.
Like there's private and then corporate, and
Yeah.
I don't know if that's
See, and that's why I'm not even looking at the data. I'm looking at how they presented the data. I'm assuming the data's right. It's negative. You're good catch, Brittany. I wasn't even looking at that. Here's the deal. Let me ask you another math question. If instead of looking at the area that's purple, I simply looked at the width of each circle instead of the area, how would that compare to the area? Josh?
Multiply it by pi.
Oh, good. So,
You know what, actually, I can almost prove that this map was made by a no campaign.
you can, can't you?
Yeah.
Yes, you can. Go. Jory, hold that stuff for just a second. Just a second. I want to come back to you in 30 seconds. So when you calculate the area of a circle, you probably have forgotten this, and it's okay. We'll come back to it. If you have the diameter, to find the area, you multiply by pi over 4, and then you square the diameter and multiply by that.
Yeah, that's what I was.
The trick is the squaring of the diameter. If a diameter of one circle is twice as big as the diameter of a second circle, the area will be 4 times as big. And you can see it if you draw it. Let's draw it right over here. If you take a circle that's that big, and you take a circle that's that big, which has twice the diameter, you can see that more than just 2 of the circles fit in there. There's room up here and here. And it's because of that formula. Well, it's because of the formula of area in particular. So what the no campaign most likely did, if it was them that did it, was they made the no, or the yes campaign, excuse me, they made the votes look bigger visually, trusting that we wouldn't look at the data, and just to give that, wow, there's way more no than yes.
Because that's the initial response, right? You look at it, but then you look at the amount of green too in the areas where there is a lot of purple. And those contributions, my guess is going to be that they were bigger to fight the no in that area.
Well, sure, and you guys are going way deeper than I'm going. I'm just saying, I think this was made, now my personal vote is this was made by the yes campaign to show how nasty the no campaign is. Look at how much money they're giving to keep your food unsafe, and this is, I'm not picking a side here, although I am without saying anything.
Oh, you said
I know. But the idea is that that's a misleading use of scale. This is roughly twice as big as that. It's actually closer together than it was. It was 1.9 to 1 last week, and it's changed a little bit now.
Oh, wow.
Yeah, so the idea is, if this is 1.9 to 1, the areas should be 1.9 to 1 as well, but they're not. And that's the idea, Jess, it's back to your question of scale. It's all about scaling. Please, Amy, go.
When it says click on a circle for more information, is it just political or is it mathematical?
I have no idea, because I haven't actually found the raw data. All I find is JPEG links, so the links are dead.
I was curious if it
Mm-hmm.
showed your numbers.
I know, I would love to see it too, but I can't get past the math of it. That's the part, I can't even take it seriously because the math is wrong. So, I'm with you, I haven't found the actual raw data yet though. Yeah, Drew.
Really fast too, I have a disagreement with the way that they wrote a campaign contributions by zip code. That means that in each zip code, they should be having a green circle, or a blue circle, or a purple circle.
I
Sorry,
think they
that's
do.
huge.
If you look at Portland.
But if you look over there at the big one, the huge circle, that's
That
covering
can't be one
that's
zip code.
covering Missouri, Kansas, Arkansas, Illinois. That is not one zip code. I can almost guarantee.
Well, actually, hang on. This last week, this had all of the campaign contributions from Monsanto, which is in that zip code, and the entire circle was all from that zip code.
Really?
Yeah, because that's how much Monsanto has poured into it to fight it. You see what I'm getting at? I mean, I know it's hard to believe, but it's hard to believe what they're doing.
That's weird.
It's hard to believe as a human being what they're trying to do. I'm sorry.
This is a weird scale.
But this is very, that's
Yeah, it
politics.
is.
So, right, yes, it is, but it's very much, but it doesn't mean the math can't be right.
Yeah, the math.
The math would still be staggering if it was done correctly. It just wouldn't be twice as staggering like it is now.
Yeah.
So Jess, a very long-winded answer to your awesome question. But just pay attention, because this is, when does this get voted on? A couple weeks?
November 4th.
Yeah, a couple weeks. So just pay attention, because the whole country apparently is involved in it, so. All right, anyway, didn't mean to take us down that road. What the hell? It was a good road to go down.
Sorry.
Hey, no, don't be sorry. It was a great road to go down. Be aware, guys, be aware of this stuff. It's in your world. This is data that's coming across your page.